today we're going to look at the derivative of a to the x. What this means is that the x is in the exponent and the x is no longer the base. So keep in mind this is different than writing x to the a or x to the n, because the derivative of this is just n to the x n minus 1. This is a completely different thing than what we're talking about. So this is like 3 to the x, 4 to the x. These are exponential functions. And there's some things we need to remember property-wise about them. The first thing that we need to remember is we need to recall that e to the power of ln of a is just equal to a. Okay, that's one of the properties we need to remember. Another one is that x times ln of a is equal to ln of a to the x power. Okay, those are two properties we need to remember. So let's just observe really quick something that's going to happen. E to the power of x ln of a is equal to e to the power of ln of a to the x. Right? This x moved up to the power up here. And then this is going to be equal to a to the x power, because the e and the ln simplify each other. Okay? So we're going to use that in order to start with the function a to the x, and we're going to take the derivative with respect to x. Okay, and we just noticed that a to the x is the same as this. Okay, they're the same thing. So I'm going to rewrite this as e to the x ln of a and then the derivative of it. So again, the a of x, a to the x power, is this right here. They're absolutely equivalent. They're absolutely equivalent. Okay? So now we're going to use what we know about e to the x and the derivative to actually take the derivative. So whenever we take a derivative with respect to x, what we're going to do is we just write it again, so it becomes e to the power of x ln of a times the derivative of the exponent, right? So we're taking the derivative of this piece. All right, so this is e to the power of x ln of a times, and here we have to use the product rule. So the derivative of the first is just 1. So you get ln of a plus x times the derivative. Now, keep in mind, this whole number, that's a number. So that's a constant. And the derivative of a constant is 0. So 0 times x is just going to be 0. So you get e to the power of x times ln of a times ln of a. Okay? Now, we're going to substitute back in. This right here, as we said before, is equal to a to the x. So this is going to be a to the x power times ln of a. Okay, so that's the derivative of a to the x power. So here are two rules that you can learn And what we did is we proved the pink one, is that if a is greater than 0 and a does not equal 1, then the derivative of a to the u is just a to the u ln of a times the derivative of u. Okay, that's using the chain rule, using the Leibniz notation. Without the chain rule, if you just want to memorize the shorthand for it, it's a to the x, and then the derivative of it is just a to the x times ln of a.